Hello students, I am Nilanjana Sanyal, an online math tutor from India. Welcome you all to my channel NS Online Math Classes. Now we are learning about the binomial expansion when the power of the binomial expression is a rational number. It can be a negative integer, it can be a fraction, it is a rational number. Okay? Previously, we have learnt about the binomial theorem, the binomial expansion, where the power of the binomial expression was a positive integer. And this is also the binomial theorem, but over here the binomial expansion is having a power which belongs to the set of rational numbers. It can be a fraction, it can be a negative integer, okay? It is a rational number. And in our previous video, we have seen how to compute the binomial coefficients in CR when n belongs to the set of rational numbers. N is a negative integer or n is a fraction. We have seen how to compute the binomial coefficients in our previous session. And today we will be learning about the binomial expansion, the total binomial expansion, where the power is a rational number. Okay? So without any further delay, let us start with today's session. And please stay tuned till the end. You will be knowing how to expand the binomial expansion, how to get the terms when n belongs to the set of rational numbers. Okay? So let's start. Now this is the binomial expansion for a plus bx whole raised to the power of n. Over here a and b, these are constants. Over here we are seeing a plus bx is the binomial expression because it contains two terms, and we are having this x in only one of the two terms. Okay? Because you will not be having a binomial expression which will be containing x in both the terms, and the power of the binomial expression will be a rational number. You will not be having any such question in your IB math board examination or in your A-level math board examination. Therefore, we will be considering only binomial expressions where x will be present in one of the two terms, okay? And a and b are constants, and n belongs to the set of rational numbers, okay? Now, a plus bx whole raised to the power of n can be written in this form. A plus bx whole raised to the power of n can be written as, I can take a as the common factor, I can take out a, and it will be 1 plus b over a times x, okay? And this is getting raised to the power of n. Now we can separate the two terms and we get a raised to the power of n, which is this one, and 1 plus b over a times x raised to the power of n, which is this part. Okay? That is how from a plus bx whole raised to the power of n we are getting to this form. Okay? And n belongs to the set of rational numbers and r belongs to the set of whole numbers. R starting value is 0 and it continues. It increases by steps of 1, 0, 1, 2, 3, 4. This way the values of the value of r goes on increasing. Okay? So a plus bx whole raised to the power of n can be written as a to the power of n. Obviously a is a constant raised to some rational number power. This is a constant. And then comes the expansion of this part. 1 plus b over a times x whole raised to the power of n. And what will be the expansion for this part? Now you see the difference between what we had done previously and what we are doing now when the power is a rational number. Previously, the power was a positive integer, and then the starting value of r was equal to 0 and the ending value of r was equal to n. But when n is a rational number, the starting value of r is the same, it is 0, but the ending value is infinity. Meaning this is an infinite sequence. I had said in my previous video that there will be some differences. It will be mainly the same, but there will be some differences. I had said most probably minor difference or slightly different, something of that sort, because it is not that r equal to 0 to n and r equal to 0 to infinity, the difference is very little. One is a finite series and another is an infinite series. The difference is not at all negligible or very little. But I have used this word slight difference or whatever I have used in the sense that the working that you will be doing or will be needed will be more or less the same. You have to just remember that when n belongs to the set of rational numbers, the series that we get is an infinite series. It is not a finite series like we have seen before. Okay? But obviously you do not have to take the infinite series. You will be asked to give the first 3 terms, 4 terms, 5 terms. So that is a finite series. Okay? You cannot approach infinity, or you can just move towards infinity, but you cannot reach infinity. So you cannot write all the terms of this expansion. You can write all the terms of the binomial expansion when n belongs to the set of positive integers, but not when n belongs to the set of rational numbers. Okay? Because this is an infinite series. And but the pattern is the same. You see, in CR, what was the general term expression? It was in CR, the first term raised to the power of n minus r. The first term is what? In this case, it is 1. So it is 1 raised to the power of n minus r, and b over a. I am not having sufficient space. I don't know whether. Okay, let me try. B over a times x raised to the power of r. Okay, fine. I have succeeded in writing. So, 1 raised to the power of n minus 1, 1 to raised to the power of anything is equal to 1. Therefore, in this expression, you don't have this 1 part. Because it is 1. 1 multiplied with anything will be that part. So, I do not have to write this 1 explicitly. Therefore, there is no 1 in this expression. B over a times x raised to the power of r is present, in CR is present, but this part is absent because this part is not contributing anything new. Okay? So, a raised to the power of n is over here, and we are expanding this part, which gives us this infinite series. R starting value is 0, ending value is infinity, in CR and b over a times x raised to the power of r. And in CR is this, the denominator is r factorial, the numerator starting value is n, it goes on decreasing, and what is the last factor? We come to the last factor when r minus 1 gets subtracted from n. And we had seen in our previous video, when we were computing the different binomial coefficients, we had seen when r was equal to 1, we were having a single factor in the numerator. When r was equal to 2, we were having two factors in the numerator. And we will be seeing that again in our today's session when we will be solving the questions. Okay, so this is the binomial expansion, and since this is an infinite series, we have learnt about the infinite geometric series, and we have seen that an infinite geometric series converges to a particular number or a particular value only if the absolute value of the common ratio is less than 1. Similarly, this infinite series will be converging to a particular value if the values of x follow this inequality. Absolute value of b over a times x should be less than 1. This is known as the interval of convergence. If b over a times x, the absolute value of b over a times x is less than 1, only then will this infinite series be converging, will converge. Okay, which means this. How do we come to this? The absolute value of b over a times x is less than 1, which gives us this expression. Either b over a times x is a positive number, is less than 1, or if this b over a times x is a negative number, then negative b over a times x will be less than 1. Because if b over a times x is a negative number, then negative of negative number will be a positive number. So this will be less than 1. Okay? Or if we multiply both the sides of this inequality by negative 1, the sign will be changing because we are multiplying with a negative number. So we can write this 1 times minus 1 is minus 1. So it is b over a times x is greater than minus 1. So b over a times x is less than 1 and b over a times x is greater than minus 1. So where can I write? Let me write over here. So we have minus 1 is less than b over a times x is less than 1, and we have to get the range of values for x. So we multiply all the three parts by a over b, and a over b, we do not know what are the signs of a and b, so we are multiplying with the absolute value of a and a over b. So this way we multiply this with this, and I don't have space, so we are multiplying all the three sides by, this will be a over b, and this is also a over b. This is also a over b. So a over b minus times minus 1 is minus a over b absolute value of this is, and this one when multiplied together will be giving us a 1. So this is x and this is a over b. So this is what is written over here. Okay, so this is a separate part. So this is the region interval of convergence. Only if x has a value ranging lying between these two extreme points will the infinite series be converging, otherwise not. Okay, converging to a particular value. Fine. So when we have, if a is equal to 1, we have nothing to do. We do not have to take out a to the power of n. But if a is not equal to 1, then we have to convert this into this form, a to the power of n times 1 plus b over a times x whole raised to the power of n. Okay? And for our today's session, we will be taking up questions which will be having the a value as 1. In our future session, in our next session, we will be having some separate value for a. It will not be 1, but for today, the a value will be equal to 1. Okay? So let's start with our questions for today. The first question says, write down the first 4 terms of the binomial expansion of 1 over 1 plus x. So let's start with our answer. So 1 over 1 plus x. We do not have any denominator in the binomial expansion. We have not seen that so far. So we can rewrite this as 1 plus x raised to the power of negative 1. And this is the power of 1 plus x. 1 plus x is the binomial expression because it contains 2 terms. And this is the value of n. N is equal to negative 1, a negative integer. That means n belongs to the set of rational numbers. Okay? And we are asked to give the first 4 terms. Since a value is equal to 1, we do not have to do anything. We do not need 1 raised to the power of n. Because it is 1 raised to the power of n or 1 raised to the power of negative 1 is 1. Okay. So, we start with 1 plus x raised to the power of negative 1 is equal to sigma r equal to 0 to infinity in CR, that is negative 1 CR, and b over x. It was a plus b x raised to the power of n. And then what did we do? We had taken out this common factor a, and it was 1 plus b over a times x and raised to the power of n. So we had a to the power of n and 1 plus b over a times x whole raised to the power of n. And we had done the expansion of this part. Now in this case, in our case, a is equal to 1, b is equal to 1. So b over a is 1. Okay. So the expansion was a to the power of n and r equal to 0 to infinity in CR and b over a times x whole raised to the power of r. This was the expansion. And b over a is equal to 1 in our case. So it will be just simple x raised to the power of r. Okay. So x raised to the power of r. Fine. So now we have to give them the first 4 terms. So let's start. Let's start over here. Our starting value is 0. And what about x to the power of 0 is 1. And we know in C0, whatever may be the value of n may be a positive integer, it may be a negative integer, it may be a fraction, whatever may be the value of n, in C0 is always equal to 1. Okay. So this part is equal to 1, the coefficient is equal to 1, and x raised to the power of 0 is also equal to 1. So the first term is equal to 1 plus the second term. First of all, this will be x raised to the power of 1, we will be having x, but first of all let us deal with the NCR part. The denominator will be r factorial, that is 1 factorial, because r is having a value of 1. And since r is having a value of 1, therefore the numerator will be having only a single factor, that is n. It is -1, and x raised to the power of r, that is x raised to the power of 1, which is equal to x. And I have shown you why this numerator will be having a single factor when r is equal to 1 in detail in my previous video. If you have not watched that video and you are getting confused by watching this video, please do watch the previous video first and then come to this session, okay? Everything will be clear to you. So this one is the second term of this expansion. The third term plus, this time r value is equal to 2. So it is 2 factorial in the denominator. It starts with n -1, and since r is equal to 2, there will be 2 terms or rather 2 factors in the numerator, and the factors will go on decreasing in steps of 1. So it starts with -1 and then the next factor will be -1, -1, okay, times x to the power of 2. Plus, this time value of r is equal to 3. So it is 3 factorial. Okay, 3 factorial. And again we will be starting with -1, and since the value of r is equal to 3, therefore we will be having 3 factors in the numerator and they will be just decreasing in steps of 1. So -1, -1, -1 and -1, -2 and x raised to the power of 3. These are the 4 terms, okay? So now we simplify. 1 plus -1 times x is -x, so it will be -x. This one is -1 times -2 is +2, over 2 factorial is 2, so 2 over 2 is 1, times x square is x square, so it is plus x square. And then -1 and this is -2 and this is -3. So -2 times -3 is +6 times -1 is -6 over 3 factorial. 3 factorial is what? 3 times 2 times 1, which is +6. So -6 over +6 is -1 times x cube is -x cube. And this does not stop over here. It is an infinite series, but we are required to give the first 4 terms. We have given the first 4 terms. Okay. This was the answer for the subpart A. Subpart B says, use the expansion to estimate 1 over 1.1. If we relate this 1.1 to 1 plus x, we can see that x value is equal to 0.1, because 1.1 can be written as 1 plus 0.1. So x is equal to 0.1. Okay. So x is equal to 0.1. And we have to use the expansion to estimate 1 over 1.1. So we will be just substituting this value of 0.1 in this expansion. We have taken only the first 4 terms, so we will be taking only the first 4 terms. It will be equal to 1 minus 0.1 plus 0.1 square minus 0.1 to the power of 3, which is equal to, we need a calculator, it is 1 minus 0.1 plus 0.1 square minus 0.1 to the power of 3. Okay. So this is equal to 0.909. This is equal to 0.909. So we can write 1 over 1.1. Therefore, 1 over 1.1 is approximately equal to 0.909. Let us check using this binomial expansion. And it is an infinite expansion. In infinite series, we have taken just the first 4 terms of that infinite series. But let us check what is the actual value of 1 over 1.1 using the calculator. So if we try to get the value of 1 divided by, it is 1 divided by 1.1. 0.909090, so it is 90 recurring. Therefore, they have given 909. So we have got fairly an accurate answer. Okay, this is 90 recurring. So this is, and 1 over 1.1 is equal to 0.90 recurring using calculator. Okay. So therefore, we see that if we take only the first 4 terms, even then we are getting almost the correct answer of the 1 over 1.5, 1, sorry. Okay. So let us move on to the next question. Write down the first 5 terms of the binomial expansion of cube root of 1 plus 3x. Over here also you see a value is equal to 1, even though the b value is not equal to 1 in this case. Now it is a similar question. I know that this will be taking some more time and my video will be even more longer, but I thought instead of taking up a single question, because it is entirely a new concept to you, if I take up 2 questions, it will be better for you. So therefore, I have taken up this question as well in this session. Okay. So let's start with an answer. So we have to, this is insert form. First of all, we have to change it to indices form. So 1 plus 3x raised to the power of 1/3. So 1 plus 3x, it is a binomial expression because it contains 2 terms, and n is equal to 1/3, which is a rational number, it is a fraction. So we can expand this and using the binomial expansion method, and it will be an infinite series. We have to give just the first 5 terms. Okay. So what will be the infinite series? It will be, since a is equal to 1, we will not be having the a to the power of n part. It will be r equal to 0 to infinity in CR b over b over a, b is 3, 3 over a is equal to 1, therefore it is 3x, b over a times x, b is 3, a is 1, so it is 3 times x raised to the power of r. Okay, and we have to get the first 5 terms. So we write this, r equal to 0. In C0 is 1 and 3x raised to the power of 0 is also equal to 1. So the first term is 1. Second term, in C1, what is in? In is 1/3. So it is plus 1/3 C1 3x raised to the power of 1 plus 1/3 C2 3x raised to the power of 2 plus 1/3 C3 3x raised to the power of 3 plus 1/3 C4 3x raised to the power of 4. Okay, these are the 5 terms, first 5 terms. So 1 plus, now what is the value of 1/3 C1? Since r is equal to 1, the denominator will be equal to 1 factorial. And since r is equal to 1, there will be a single factor in the numerator which will be equal to n. n is equal to 1/3. So 1/3, and this is 3x. So this is multiplied by 3x. 3x raised to the power of 1 is 3x. Okay. And then 1/3 C2. The denominator will be 2 factorial, and since r is equal to 2, we will be having 2 factors in the numerator. Starting factor will be the value of n, which is 1/3, and it will be just going on decreasing in steps of 1. So it will be 1/3 times 1/3 minus 1, and that is 3 square is 9, so it is 9x square plus 3 factorial. We will be having 3 factors in the numerator. It is 1/3, 1/3 minus 1, 1/3 minus 2, and 3 cube is 27 x cube. Okay, plus 4 factorial one-third times 1/3 minus 1. There will be 4 factors in the numerator. 1/3 minus 2, 1/3 minus 3 times 3 to the power of 4 is 81. So 81 x to the power of 4. Okay. So this is equal to 1 plus, this is 1/3, so 1/3 times 3x. This one is plus 1/3 minus 1 is, this is minus 1 is minus 3 over 3. Okay, and 1/3 minus 3 over 3 is minus 2/3. So it is 1/3 times minus 2/3 times 2 factorial is 2. So it is half times 9x square plus 1/3. 1/3 minus 1 is negative 2/3. 1/3 minus 2. Minus 2 is 6 over 3. This minus 2 can be written as minus 6 over 3. So 1 over 3 minus 6 over 3 is minus 5 over 3. So this is minus 5 over 3 times 27 x to the power of 3. And finally the last one, and of course, there is the 3 factorial as well. 3 factorial is 1 over 6. Because it is 1 over 3 factorial, so it is 1 over 6. And then again we come to this part. 1/3 times negative 2/3 times negative 5 over 3, and then it is 1 over 3 minus 3. So minus 3 can be written as minus 9 over 3. 1 over 3 minus 9 over 3 is minus 8 over 3. Times 81 x to the power of 4. And what is 4 factorial? It is 24. 4 times 3 times 2 times 1, 4 times 3 is 12, 12 times 2 is 24. So it is 1 over 24. Okay. So these two will be getting cancelled. These two will be getting cancelled and these two will be getting cancelled. So let me write the terms. 1 plus this one is x. This one is minus x square. Okay. Next, what it is? 3, 3, 3. We can cancel them. Minus times minus is plus. Okay. And 2, this can get cancelled. Okay. So it is 5 over 3 x square. Not x square, x to the power of 3. So plus 5 over 3 x to the power of 3. And then these 4 and this one cancels, and we can have this minus times minus is plus times minus, so it will be a minus term, negative term, and this can get cancelled. 12, and I can cancel this as well. 4 times 2 and 4 times 3. Okay. So it is 10 in the numerator, 5 times 2, and 3 in the denominator, and x to the power of 4. So this one is the first 5 terms of the expansion of 1 plus 3x raised to the power of 1/3, which is cube root of 1 plus 3x. Okay. This is how we give the first 3 terms, first 4 terms. Because it is an infinite series, of course we cannot give all the terms, we cannot write all the terms, but we will be writing the number of terms that has been asked in the question. Okay. So you see, it is very easy. We do not have to just panic just by seeing that, oh, n belongs to the set of rational numbers, so it should be super difficult. It is not at all difficult. Okay. So students, this brings us to the end of this session. We meet again very soon. Thank you for watching this video till the end. Please like, share, subscribe and comment if you find this video helpful. So bye for now.